We are going to talk a little bit about radical equations here, but the first thing I'm going to do is I'm going to have you adjust your notes a little bit. Actually, I think I'm going to have you adjust them as we go. I originally thought that it would be a good idea to talk about fractional exponents at this point, but I've since decided that I'm going to hold off because we are going to talk about fractional exponents quite in depth in another unit. So I'm going to come back to the problems that have fractional exponents. So that being said, I'm going to cross out this number 2 here, and I'm going to cross out this number 2 down here, and I'm going to change it a little bit. I'm going to change it to be 2 times the square root of x minus 2 equals 50. That being done, now I'm going to go ahead and I'm going to talk about what a radical equation is. It's an equation with a variable under a radical. So if I look at these, I guess 3, because I crossed one out, these 3 examples here, and I answer, are these radical equations? Well, I check. I have a radical under, or excuse me, I have a variable under a radical. I have an equal sign, so it's a radical and it's an equation, so I'm going to say yes. On number 2, I only have a number under a radical. My variable is not under a radical, so no. And on number 4, even though it does have the variable under the radical, it is not an equation since there is no equal sign, so I will say no. So how do I solve a radical equation? Well, very similar to absolute value equations in the aspect that I'm still going to start by isolating a radical on one side. So for example, on number 1, if I have the square root of 5x plus 1, subtract 6 equals 0. In order to isolate or get the radical all by itself, I'm going to have to add 6 to both sides, giving me the square root of 5x plus 1 equals 6. That's not a 6. Equals 6. Now that I have the radical by itself, I have to figure out a way to get rid of a square root. Well, absolute value equations are tricky because the only way to get rid of an absolute value bar is by setting it equal to the plus or minus. Radical equations are much nicer in the aspect that a radical or a square root has an inverse operation, just like adding and subtracting, multiplying, and dividing do. To get rid of a square root, we take and square it. I must do it to both sides. My square and square root cancel, leaving me with 5x plus 1. 6 squared gives me 36. I subtract 1. I get 5x equals 35. I then, going up here because I'm out of room, divide by 5, and I get x equals 7. If I check my answer, does 5 times 7 plus 1, then subtract 6 equal 0? Well, that gives me the square root of 36 minus 6, and you bet that equals 0. So my solution is x equals 7 for this first problem. One thing I want to point out, because I see students make this mistake constantly, you cannot square here. People think they can square here and distribute the square to the radical and the 6. Remember that activity we did those first week or 2 of school? You saw you cannot distribute a square into add or subtract. You cannot distribute a square to a binomial. The way to square a binomial is write it twice and FOIL, or distribute if you don't like to use the acronym FOIL. Writing this twice and foiling it sounds like a nightmare. So instead, be sure you follow these steps. Isolate the radical on one side, then raise both sides to the same power. Let's look at example 2, the new one. So I cannot distribute into radicals. I can only distribute into parentheses. So I'm going to go ahead and get rid of that division so I can isolate the radical by dividing by 2, giving me the square root of x minus 2 equals 25. From here, I want to get rid of the radical, so I know to get rid of a square root, I square it. I square both sides. That leaves me with x minus 2 equals 625. I'll add 2, and I get x equals 627. I like to check my work, so I ask myself, does 2 times the square root of 627 minus 2 actually equal 50? Well then, does 2 times the square root of 625 equal 50. I know since 25 squared was 625, the square root of 625 must be 25. And since 2 times 25 does equal 50, I'm happy with the solution I got.